What's going on, Mathaholics? Now we're going to do the exact same thing as we did in the previous video, except with the negative exponent. So let's go ahead and see what we do. Now remember how I gave you the little example where whenever we have a base of 10 raised to some exponent, we're going to get rid of that 0, just write it as a 1, and then remember what I was saying? Good. Well, now that we're doing it with negative exponents, we can't really do that because we're going backwards. So if we got rid of that 0, it just wouldn't really make sense. So just keep in mind, you can do what I said in the last video whenever you have a base of 10 raised to a positive exponent. But when we have a negative exponent, it's just going to be a little different. Different doesn't mean harder, it just means a little different. So as long as you pay attention, you might want to re-watch the video or pause it, take notes. I guarantee it'll be just as simple. Okay, so 10 to the negative third. When we were doing our last video, I asked you, where does the exponent go? Sorry, not the exponent, the decimal. And we said it goes at the end of the number. That is the exact same thing we're going to do here. So we're going to put our decimal right here, okay? And I know that does not look like a decimal, so there. And now this 3 is going to tell us how many times we're going to move that decimal. So let's go ahead and move it 3 times. This time, we're just going to go to the left. So let's move it left 3 times. 1, 2, 3. Okay, now what do we do? Wherever you see a gap before the first digit, before the first non-zero digit, you are going to put in a 0. So here's a gap before the 1, and here is also a gap before the 1. Right here, this gap comes after the 1, so we're not going to put another 0 there. It's just going to be these two right over here. So that's all we have to do. We're going to put 2 zeros in first, and then the 1. And where did we move our decimal? Remember, it was at the end of this original number right here, and we moved it over 3 times. So let's pretend it was still here. 1, 2, and 3. And that's the answer. It's just like that. I'm going to do a couple more. I'm going to re-explain this one just to make sure that it makes sense, because if I'm being honest, when I was learning this, it took me like a week and a half, and it should not have taken that long. So I don't want it to take that long for anybody else, which is why we're going to do it again till it's just second nature. 10 to the negative third. How do we do this? Where does our decimal start? It starts at the end of that number. How many times do we want to move it over? 3, because that exponent tells us so. 1, 2, and 3. Am I going to put a 0 right here? No, because that comes after the 1. Where are my zeros going to go? Every little gap I see before that first number. Here's a gap before the first number. Here's a gap. I know it kind of looks like it's underneath the first number, but it's just because that's how I'm drawing on this drawing pad. But I'm sure you get the point. So we're just going to put our zeros in. And remember, we moved that decimal over 3 times, so that's what we do, 0.001. Simple. Let's try again with a different problem. 10 to the negative fourth. All right, where does our decimal start? Starts right over here. Move it over 4 times. 1, 2, 3, and 4. Fill those spots in with zeros. 0, 0, 0. And then where does our decimal go? If you want to see it one more time, we just go 1 time, not here, 2 times, not here, 3 times. That is getting really clustered, so I'm just going to rewrite that. 0, 0, 0, 1. I missed one there. The decimal, let's pretend it's still here, but we need to go over 4 times. Not here, 2, not here, 3, not here, 4. Right over here where this red decimal is going. Pretty simple. I'm still not just going to move on though, because if you haven't gotten the way of like do things now, I just really like to make sure things are clear. So let's do it one more time. 10 to the negative fourth. And if you already understand it, feel free to skip ahead. But if you don't, then stick around. So that's going to tell us we need to move our decimal that's currently right here over 4 different spots. I'm just going to write it here so we have more room. 1, 2, 3, 4. Fill that in with zeros, 0, 0, and 0. and then that's where our decimal is now. I did not mean to delete that 0. I'm sure you get the point by now. I probably didn't need to explain it that last time, but I still did. Now let's look at some more complex problems. And by complex, it's not really complex. You'll see. So let's say we have 0.00125. And now we want to get it into a different form. We want to get it into the form that this one was written in. How do we do that? Our decimal is going to want to be right after that first non-zero number. So what is the first non-zero digit? It's this 1. So we're going to want to put this decimal right after that 1. Let's go ahead and do that. 1.25. Okay, and now how did we go from this to this? Well, just like I'm sure you did on your paper, we just moved the decimal over. Now, can you just write, oh, I just moved my decimal over? Nope, we have to say how many times we moved it over. So let's just count. 1 time, 2 times, 3 times. And what is it that we did in the last video when we were doing problems with exponents raised to the positive power? We did times 10 to however many times we moved it. And that's the exact same thing we're going to do. 1.25 times 10 to however many times we moved it, sort of. Right here it says, whenever we move the decimal to the right, the exponent becomes negative. I know we've always learned that whenever numbers go this way, they get bigger, which is positive. Whenever they go this way, they get smaller, which is negative. But for scientific notation, we are going to pretend like that never existed. So let's just do this one more time until it becomes second nature. It's over here. We want to get it into our new format. Here's our decimal. We don't like it there. 1 time, 2 times, 3 times. That now becomes 1.25. And now what is it that we always do, regardless of whether it's positive or negative? Times 10 to however many times we moved it over. In this case, we moved it over to the right, which makes it a negative. Unfortunately, it's more confusing, but just remember that. And that's it. That's all you have to do. So I'm going to do a different problem. If you already understand it, then you don't have to keep watching, but if you want to have more practice, then go ahead. And in fact, if you made it this far into the video, comment down below. The first person is going to get a Cane's gift card. First person that I see comments. If anyone ever comments, who knows. So here we have 0.00179. We want to get it into that same format we were just looking at these problems in. What do? Where does this decimal need to go? It wants to be right after that first non-zero number. That 1 is the first non-zero number, so we're going to move it over to where it wants to go. 1.79. Okay, how many times did we have to move it over? 1, 2, 3. Okay, we always do the times 10, and then just going to write that 3 down. Now, is this 3 going to be a positive 3 or a negative 3? I'm going to give you maybe like 3 seconds to think about that. 1, 2, 3. I hope you said a negative 3. And why is it a negative 3? Simply because we moved to the right, as our little rule says right here. I hope this makes sense. I know it can be a little confusing at first, but that's why we get videos so we can watch them over and over and over again. If you have any questions, please leave them down below or send me an email, and I'll make sure to respond to everybody just so that we can understand this concept. Thank you, and I hope you learned something.